Hello everyone and welcome back to our channel Quaint. Today we will explore the secret behind digital text from ASCII to Unicode in this video. So every word you are reading right now, that is the video title, or every message you have ever typed, and even the emojis you use daily, all these things are what? All these things are nothing but numbers. Yes, text in the digital world is just a clever arrangement of binary codes. Yes. So question is, how do computers actually represent letters, symbols, different characters, emojis, etc.? How do computers represent all these things? So if you study computer science, then you can see that there's actually fascinating trick they use. Computers actually don't know what letters are. All they know is binary, zeros and ones. Yes, computers know only these things, binary, zeros and ones. They don't know letters or symbols or any other character or emojis. They don't know. So answer, what is the answer? Then how actually computers display, say for example, the word hello on the screen? How computers do this thing? So answer lies in the encoding systems like ASCII and Unicode. Yes, what is done actually? Any letter means all the characters, whether these are letters, say for example English letters, English alphabets, 26 uppercase letters are there, 26 lowercase letters are there. If you think about digits, then 10 digits are there, 0 and 1 to 9. 10 digits are there, some symbols are there. So all these characters are mapped to a number. That means all these characters are assigned a unique number. Just for example, the uppercase letter A in the English alphabet is assigned the value, numeric value 65. And the uppercase letter B is assigned the numeric value 66, and so on. Similarly, @ sign rate is there, @ sign symbol is there, then hash symbol is there, percent symbol is there, the signs are there, and all these things are actually assigned a fixed value and unique value. Okay, so there are two systems I have already mentioned, ASCII and Unicode. So in case of ASCII, actually in early days, ASCII was used. ASCII was designed by engineers. ASCII stands for the American Standard Code for Information Interchange. And the ASCII system uses actually 7 bits. And this could represent a maximum of 128 characters. That is a 2 to the power 7, 1 which is equal to 128. So this ASCII 7 system could represent only 128 characters. But this is enough for English alphabets. How many English alphabets are there? Letters are there in the English alphabet? 26 uppercase, 26 lowercase, that is 52. Then 10 digits makes 62, and some symbols. All these things could be represented by using that ASCII 7 system. But this system, this ASCII 7 system, the uppercase limit is 128 only. That's why this system is not enough for the rest of world's languages. So many languages are there, you know. Hindi, Japanese, Chinese, Korean, Urdu, so many languages are there. So what happened actually, when computing spread globally, the ASCII system fell short. So we needed something bigger, and that's why Unicode was designed. Unicode was designed for what? For universal character, means to represent universal character sets. Okay, Unicode, the purpose of designing Unicode was what? Just for universal reach. Okay, and it actually, this Unicode system actually provides us a space for more than 1 million characters. Yes, more than 1 million characters. And at present actually more than 149,000, that is 1,49,000 characters. Unicode consortium is using bunch of characters at present. I am talking about that UTF-8 system. Anyway, for that purpose I will make a separate video. So Unicode system is doing this thing. They are also assigning numbers, unique numbers to the characters. For each character an unique number they are assigning, and these unique numbers are called code point in Unicode system, code point. Okay, for example, you know Hindi alphabets, the first vowel is A. A is assigned the value, numeric value, that is the code point value is U plus 0905. Similarly, smiling emojis. I am talking about that smiling emoji. You can see on the screen that is represented by the number. This is hexadecimal U plus F1600. Sorry, U plus 1F600. Okay. So this number actually used. You need not remember all these numbers. This is just for example I am using here. Okay. Nobody remembers all these numbers. If you are studying computer science, you need not to remember all these numbers. You need not to memorize all these numbers. Just for example, just 1 to 2 things you should remember. Anyway, so these things are done. So first numbers are assigned, then all those numbers are converted into binary system. Okay, means in terms of zeros and ones, all those numbers are actually converted into this binary system. And then these binary numbers are actually stored in the memory. Memory means, you know, RAM is there, then hard disk, then SSD devices. Anyway, so all these binary numbers are stored. And then what is the requirement to display the text on the screen? What is the requirement? The requirement is the operating system and fonts. So these code points actually are what is done next. You know, graphical design of characters remains stored in your computer. Graphical design of characters. So these code points are matched to those stored the graphical design of the characters, and that way your screen's pixels actually light them up, light them to show you, and that way you can see that the word hello on your screen. That means at the end of this video I want to say that whenever you are messaging someone, say you are using WhatsApp message, you are writing something and hitting the send button to send the message. So what happens actually in that case? You have typed what? You have typed letters. But actually letters are not being sent. What are being sent? Instead of letters, numbers are being sent to the recipient's device. Means your friend's device or recipient's device. Numbers are being sent. Your phone, your smartphone or computer, those things are actually converting your text into binary numbers. Those binary numbers are being sent, okay, and your friend's device, the device has the arrangement to translate those binary numbers back into text. They translate back them into text and they can see the text message. So directly actually you are not sending text messages to the recipients. You are typing text messages and they are converted into binary. Binaries are being sent. Binary codes are being sent, and those binary codes are translated again back into the text. Okay, so you can see the humble 128 characters of ASCII and Unicode's universal reach. So this is the secret behind digital text. Okay, so this was all about today's topic, and this is the end of this video. If you found this video interesting, so please like, share and subscribe to our channel. This is the end. Thanks for watching.